guys, Miss Kulkarni here. In this video, we will talk about reaction stoichiometry and we will work on more conversion practice. And I am pretty sure you will remember and you will understand how to convert any variables of chemical to variables for other chemical. So here is one sample reaction to begin with. This happens to be a balanced reaction, which is great. But keep in mind, there are coefficients for each of the reaction. If there is none, that means it must be 1. That coefficient tells you number of moles for each of the chemical. What is the roadmap? In roadmap, we find out which is our starting point and which is our destination. This will make you understand the process easily. The mole is the heart of chemistry. And then you got a reaction in which you got two chemicals, reactant A and reactant B. And these are all the variables for reactant A. These are all the variables for reactant B. You can begin with any of the variable for A and then you can go to the molar B and you can go to the variable for B. It is that simple. And I'm going to use the wording here. This is the mole bridge. So as long as you remember the conversion factors or what I call is currency, we should be all set. So let's begin working on our first problem in this practice. Notice first which are the reactants and you may have to predict the products. Okay, so there you go. This is my balanced reaction. I also want to give you one hint. Usually when you write water, it helps if you write water as HOH. So it's hydrogen and hydroxide, both are split, and then potassium goes with hydroxide, and that's the way we get KOH and then hydrogen over here. So we got our reaction ready to go with the number of moles for each of the chemical. For hydrogen, there is no coefficient. That means it must be 1. This is our next step. So we are beginning our journey from potassium. So my arrow starts from potassium and then we need to end to hydrogen. And what we need to find out? How many liters. So I wrote that and then I put the given, which is 0.056 grams right over here. Then the mole bridge, we need to make sure we are going through the mole bridge. So you go from grams to moles of A because our starting point is A. So it will be moles of A. We take our walk all the way on the mole bridge and come to moles of B. And from moles of B, we get to grams of B. So let's put our roadmap in dimensional analysis. So here we go. My beginning point is grams of A. My next step is I come to moles of A. So I'm going to write here moles of A. From moles of A, you go walk across the mole bridge and you go to moles of B. And from there, you're going to go to liters of B. We got our roadmap into dimensional analysis. What do we do next? We need to make sure that we cross out all those units. Cross. So that's grams of A. This should be grams of A. This is moles of A. So over here, it should be moles of A. And moles of B. So this should be moles of B. So diagonally, you have to make sure that you are getting exactly same units. Now, we need to make sure we plug and chug the values there. So, anytime there is mole and gram ratio, moles to mass or moles to particles, whatever we are doing, moles to any variable will be always having mole equal to 1. How about this one? It's moles to liters of B. Again, the mole will be equal to 1. What do we write when it is gram? When it is gram, that's always going to be the molar mass for A. A is potassium, so we need to make sure we write the molar mass, which is actually the atomic mass for potassium, which is 39.10, and that you can find out from periodic table. This is molar B going to liters. Remember, hydrogen gas is given to you at STP. What does that mean? That value will be always 22.4. So we got that over here. Then the beginning point, that's always the given. So I'm going to put here 0.056 grams over here. Now the only thing which is remaining is ratio of A to B, and that's pretty simple. You're going to go back to your reaction and check the coefficients. So for A, the coefficient is 2. So there you go. I'm going to put 2 there. For B, there is no coefficient. That means it is 1. So I'm going to put 1. What do we do next? We look at our units and we cross out, cancel those similar units. So there goes grams of A. Goodbye to grams of A. There goes moles of A. And finally there goes moles of B. So what are we left with? We are left only with liters of B. So you know already your final answer will be liters of B. And your goal is to multiply all the numbers and then divide. And I am just going to give you the answer here, which is 0.16 liters of B. Just keep in mind, why did I round this answer to 0.16? This is 2 sig figs, and the given number which you got here, 0.056, also had 2 sig fig. So keep in mind, your answer must match with the sig fig of the given. Okay, are we ready to get one more reaction? Let's do it. So I got some things already ready for us. Let me explain. Your compound is tin 4 nitride. I got the formula for tin 4 nitride. Sn is plus 4. That's what it means by 4. Nitride is negative 3. So if you cancel out the charges, what we get is 2 times plus 4 and 3 times minus 3. So your compound is Sn3 and N4. Then it tells you it is decomposing 2 elements. So basically you're going to break this apart and get those elements. Keep in mind, we always write the element as, if it's a metal, we only write the symbol as it is. So we are not going to put Sn3. In fact, we are going to put that as 3Sn. And this will be nitrogen. Remember, that's one of the diatomic. So you have to make sure that that is N2. Balance the reaction and our reaction will be ready to go. The next thing which I did was, I know I'm going to go from this compound Sn3N4 to Sn10. So I label those as A and B. And then I got this roadmap ready, which goes from Sn3N4 to Sn. Also, I need to find out how many grams are there. So I put my destination there, and then this is what is given to it. You always have to go through mole. You cannot just jump across and go to different variable. So we got here particles going to moles of A because we are still traveling in the area for A. Then we are going to take this bridge, and when you take the bridge, you come over here and you get to moles of B. And from moles of B, you can find out the variable which we need to figure out. So as you know, I took all those values and I tried to put those into the grid to complete my dimensional analysis there. So basically that's my starting point particles that goes here. Then I came to moles of A which went over here. Then moles of B which came over here. And I need to find out amount in grams. So that's where I'm going to end. Now we need to make sure crisscross we are going to cancel the units. So what do we get over here? Look at this, bingo. We are going to put crisscross particles here, moles of A here and moles of B here. Next thing is we are going to put the numbers, and there we go. We put 1 for mole of A at both places because Remember, mole is always number 1 with any other variable. Then we put your starting point which is given to you, and now you have to remember, if it's a particle, your currency is going to be Avogadro's number that goes over here. If it is going to be grams, you're going to get the molar mass. So I found out the molar mass for B, which is 10 here. And now the next thing which you're going to do is crisscross, cancel those units. So I end up only having grams of B left. And I'm going to calculate, multiply, divide, and what I got was the final answer, which is 26.7 grams of B. Keep in mind, the rounding is 3 sec figs. And why do we do that? Because your given number is 4.51 times 10 to the 22. We look at 4.51 and that is only 3 sec fig. So what do you think? Don't you think it's pretty easy? Well, I hope you guys enjoyed the video, and I will see you again in next video. Until then, bye-bye.